Today we are going to be reviewing solving compound inequalities. So more solving inequalities practice.
Is that it?
No, that's not it. That's the first thing we're going to do. We're also going to have a look today at absolute value equations. All right, so again, two review topics, but topics that are very important, topics that will be heavy on the final exam. What we're looking at right now is already stuff that I'm going to expect you to know for the final exam. When we're finished with this little unit on solving equations and inequalities, we're going to do something new. We're going to solve absolute value inequalities. And we'll have a test sometime next week on equations, inequalities, compound inequalities, absolute value inequalities. All right, after that, we're going to finish the year doing a whole unit on quadratic equations. Solving quadratic equations by factoring, solving quadratic equations by quadratic formula. Okay? We'll also do a good bit more with graphing, vertex. We've done some of that already, but we'll do more. We have done vertex in here, right? X equals negative b over 2a, axis of symmetry. Okay, excuse me. So that's what how we're going to finish the year. And we're close to finishing the year, which is good. Let's finish strong. All right, who can remember the two types of compound inequalities? And or is correct, right? So compound inequalities can either have the word and between them, or they can have the word or between them. What do these two types of compound inequalities mean? One of them is very exclusive and one of them is very inclusive, right? Which one is exclusive? Which one? And is exclusive, right? In the English language, it's inclusive. Yeah, Mackenzie and Ariana are going somewhere. That's inclusive. Okay? In the English language, or is exclusive. Mackenzie or Ariana. That means one or the other, right? In math, it's exactly opposite. Just like we talked about yesterday, I think we had some kind of conflict over what less than or equal to means. It's either one. It can be less than it or equal to it. So that's, either condition is met, then we're good. And is exclusive. When we first introduced this topic, what we talked about was where would you be if you had to be in the intersection of Goodman Road and Getwell Road? Right? We're all familiar with this horrible intersection in the mornings. If we're on Goodman Road and Getwell Road, where are we? It's a very, very little bitty space right there in between the two things. It's where the two things intersect. So when we're talking about the word and, we're talking about intersection. We're looking for crossover. What points do they share in common? Okay? Now, if I could be on Goodman Road or Getwell Road, that means I can be anywhere on this road. Goodman. Anywhere on this road. It's very inclusive. If I'm on one or the other, I can be all the way up in Memphis on Getwell. I can be all the way south almost to Tate County. I can be all the way over into Marshall County on Goodman Road, or all the way over by the river. I mean, that's a very inclusive. Or is the union of two things. So if we're graphing an or, what do? If I'm graphing an or problem, I do just like I just did. You shade everything. If you're graphing an and, what are we looking for? Only where they cross over each other, right? So, and we're only going to shade where they cross over each other. Let's work a couple of these, just so we can kind of recall. Intersection is what we're looking for with and or in mathematics is the union of the two sets. You just join the two things together. Understanding that intersection and union is what we're looking for. Union just means join together. So if we're doing an or problem, we're just going to graph them on the same number line and be done with it. Ands are a little bit more complicated. All right, so let's have a look at a couple of examples here. Let's do 2x plus 3 is less than 7, or 2x plus 1 is greater than negative 5. No, that's not going to work good. Change the signs. Change this to negative 7 and this to positive 5. So I'm making these up on the fly, so I might have to adjust. Okay, how would I solve the inequality on the left? Subtract 3 from both sides, right? And that gives us 2x is less than negative 10, which means x is less than negative 5. Right? Is everybody good with that? If I solve the inequality on the right, what would I do? Subtract 1 from both sides, correct? And then that would give us 2x is greater than 4, which means x is greater than 2. Now, what's the most important word on the page? Or. The only word on the page, right? Or tells us the relationship between these two graphs. Or tells me I'm going to join these two solution sets together. It's one or the other. All right, so on our number line, we're going to do negative 5, positive 2. Open circle, shade to the left. Here we'll have an open circle and shade to the right. Okay? Now, interval notation. It's still kind of new for us.
Do we have to do that?
Yes, we're going to do interval notation for these as well.
For like separate inequalities or like for both of them together?
Well, you can't do both of them together because they're separate, right?
Okay, yeah, that's what I thought.
Yeah, so I have to express this as two separate intervals. So what would the interval on the left be? What number is way down here to the left? Negative infinity. So this interval would be negative infinity up to negative 5. Parentheses everywhere, right? Because the circles are open and the infinities are always there. And I'm going to use the word or here. The interval on the right goes from 2 to infinity. Easy enough? Now, the mathematical symbol for the word or is this. And you may have seen this in some of your earlier math classes. That's the union symbol. Intersection is upside down U. Okay? So that is what you would most likely see in a textbook. You'd see that U symbol. The big U means the union of those two sets.
We just put
Or is fine.
Thank you.
Okay? Any questions on that? Does anybody have any issues with that? Now, before you get too kind of used to this concept or idea that these OR problems always go in the opposite direction, let's look at another one. All right? Y'all ready to go? You okay with this one? All right, let's take 3x plus 5 is less than or equal to 7 plus x. Or x plus 3 is greater than negative 8. Again, we need to remind ourselves that all along we're dealing with an OR problem here. The OR is the most important thing written down here. It tells us the relationship between these two equations. Okay, what will I have to do on the left to solve this equation first?
Subtract
Got to get the x's together. Got to get the x's together. So subtract the x from both sides. Gray, you with me? All right. And that'll give us 2x plus 5 is less than or equal to 7. Next, subtract 5 from both sides. And that will give me 2x is less than or equal to 2. Divide both sides by 2, we get x is less than or equal to 1. It's 1. Okay? Is everybody good with that? The other one's quick and easy, right? What is it? Subtract 3 from both sides and we get x is greater than negative 11. Okay? Now, I'm going to erase some stuff here to make room for the graphs. But, so the solution on the left side is x is less than or equal to 1. And we have or x is greater than negative 11. Now, here's what you're going to be tempted to do because you're used to what these or problems look like. Here's what you're tempted to do. What are our two numbers on our number line? Negative 11 and 1. Now, what are you going to be tempted to do? Shade opposite directions, but is that what these inequalities are telling us to do? No. To graph an OR problem, you just graph these two things together. Whatever happens, happens. It's a union of two sets. Okay, so x is less than or equal to 1 is a closed circle and shade where? To the left. That's odd, right? It's different.
Negative 8 minus 3,
Same signs, add and keep the sign. Now, x is greater than negative 11 is an open circle here and shade which direction? To the right. Do I stop when I get to 1? No, because all these numbers over here are also greater than negative 11. And what have I shaded? The whole number line. So what's my solution? All real numbers. Okay? My solution here is all real numbers. So OR problems can definitely have a solution of all real numbers because you can end up shading the entire line because they just shade right over top of each other. How do we write that in interval notation? Negative infinity to positive infinity. Okay? Now, let's take this exact same problem. Let's take this exact same problem. Let me erase some stuff here. And let's change or to and. Okay? And. I want you to rewrite the problem because this is a different problem. Right? The power word has changed. The word showing the relationship between these two inequalities has changed. So it's going to be very important to note that difference. Three x plus 5 is less than or equal to 7 plus x. And x plus 3 is greater than negative 8. Now, we've already solved these. We don't need to do that again. What was the solution to the left? X is less than or equal to 1. And on the right, it was x is greater than negative 11. But this is an and problem and not an or problem. So in an and problem, we're looking for what? Intersection. We're looking for where these two graphs cross over each other. And if they don't cross over each other, then we have no solutions. Okay? So an and problem can actually have no solutions. An or problem is going to have a solution. Because you're just cramming two answers together. You're guaranteed you're going to get an answer with an or problem. With an and problem, not necessarily. Okay, so we're looking for a crossover, and this is where we graph them above the number line. So I'm going to take negative 11 and 1. Because I'm looking for where they cross over, I'm going to graph these up top. X is less than or equal to 1 is a closed circle and shade that direction. X is greater than negative 11 is an open circle and shade this direction, right? Where do they cross over each other? In between negative 11 and 1. But we have to make a decision here about which one is included and which one isn't included.
One's included.
1 is included. Why is 1 included? Because it's shaded on both graphs, right? Is negative 11 shaded on both graphs? No, it's an open circle on the bottom graph, right? Okay, so it's not shaded on both graphs. Negative 11 is only shaded on the top graph. It's not shaded on the bottom graph, and so it's not in the intersection. We're only looking for things that are shaded in both graphs. So an intersection is just going to be everything above between negative 11 and 1. Including 1, but not including negative 11. Now, how am I going to show that inclusion and exclusion in my brackets, in my interval? How do I show in my interval notation that negative 11 is not included, but 1 is included? Parentheses on a negative 11 and a bracket on 1. That's correct. Okay, pretty easy, right? Let's do one more of these because I want you to see this, and then we'll move to absolute value equations. Next example is, let's go with 3x plus 1 is greater than 7, and 2 times x plus 3 what did I say, 7? Was that a 7? And 2 times x plus 3 is less than negative 4. Solve the inequality on the left. What do we get? X is greater than 2 is correct. Right? Subtract 1, divide by 3. X is greater than 2. And 2x plus 6 is less than negative 4. Yeah, when you solve that, you're going to get x is less than negative 5. Well done. Subtract 6, you get negative 10. Divide by 2, you get negative 5. Now, what are you going to be tempted to do here? Because it's an and problem, you're kind of looking at this. Oh, what do we do with and problems? You usually just do what? Shade in between the two numbers, right? But what are we looking for with and? We're looking for crossover. All right, so we're going to graph these. Be very careful, not going to make any assumptions. Greater than 2 shades that direction. Less than negative 5 shades this direction. Do we have any crossover? So what does that mean? It means that this particular problem has no solution because there are no numbers that satisfy the first equation and the second equation, inequality. Okay, now let me show you something here that's another little caveat of this problem. I want you to just change. Look what happens when we just change this symbol. So if you wanted to kind of rewrite this as another example, the example is x is less than 2 and x is less than negative 5. The graph's going to look very different. So if you just kind of go to another example here and write x is less than 2 and x is less than negative 5. What's the intersection going to look like here? X is less than 2 and x is less than negative 5. Where do they cross over each other? No, they don't cross over each other between there. Where are both graphs shaded? over here. Right? So this and problem is going to have this as its intersection points. Okay? So you got to remember, don't make assumptions with the and or problems. They don't always look a certain way. They can look different ways. We can shade one direction or the other direction. Sometimes we'll shade in between the two. Sometimes we shade nothing because and problems have no solution. All right? So the solution set here is negative infinity to negative 5, and that's it. And that's if we just change that one symbol to less than instead of greater than. All right, the other thing that I want to review real quickly is absolute value equations. Now, absolute value equations, does anybody remember how to work with those? Sorry. Yeah, the absolute value can't equal to a negative number. What is the definition of absolute value?
The absolute value of a number or a number of
Is its distance from 0. And because it's a distance, it has to always equal a positive number. All right? So absolute value equations are always going to split. We're going to split them into two equations. For example, if we had the absolute value of x equals 4, what are the two solutions to that equation? X can equal 4, or x can equal negative 4. That's the two solutions to that equation. All right? So if we made it a little bit more complicated, just a little bit, what if we had x plus 3, absolute value of x plus 3 equals 4? 1 or negative 7, right? But how do we solve that? How do we split it into two? Because we won't always be able to do these by observation. The two equations would be x plus 3 equals 4, or what? No. This thing doesn't change. X plus 3 could also equal negative 4. Just like we split the previous equation. Once you have the absolute value by itself, you can split it into two equations. X plus 3 equals 4 will give us x equals 1. X plus 3 equals negative 4 will give us x equals negative 7. Okay? Now, let's make this a little bit more difficult. Let's do this. Absolute value of 2x minus 1 equals 7. We're always going to split these things. So, Billy, can you tell me what the two equations are going to be when I split this into two separate equations? If my distance here of this thing is equal to 7, then what two values can I assign to this thing? 7 or what? Y'all tuned out on me too early. 2x minus 1 can equal 7, or 2x minus 1 can equal negative 7. All right? Doesn't that make sense? This thing in here, which I cannot break up, I cannot distribute, I can't do anything, that's one thing. If that one thing has an absolute value of 7, then that one thing has to either be 7 or it has to equal negative 7. Then when you solve those two equations, you get really easy, equations here. Add 1 on the left and divide by 2, you get x equals 4. Add 1 on the right and divide by 2, you get x equals negative 3. Correct? So there's my two solutions. All right? Now, the moral of the story here, or the rule of thumb that we have to play by, is that you cannot split these absolute value equations until the absolute value part is by itself. So we might have something like this. Absolute value of 3x minus 1 plus 2 equals 6. Can I split this into two equations? No, because the absolute value part has to be by itself before I split it. How do I get the absolute value part by itself?
Subtract 2.
Subtract 2 from both sides. And that gives us absolute value 3x minus 1 equals 4. Now the absolute value part's by itself. Chase, can I split it now?
Yes.
What are the two equations going to be?
3x minus 1 equals 4 and 3x minus 1 equals negative 4.
3x minus 1 equals 4 or 3x minus 1 equals -4. All right. Then what do you do on the left? Yes?
Good morning. We asked Brad to stop by this Mahoney's office when the bell rings.
He's not in my class.
Oh, my bad. I'm sorry.
All right. Add 1 to both sides. Everybody's looking for Brad today.
Because he's missed the last 2 days and he was supposed to take a test for Miss Lawrence.
Okay, 4 plus 1 is 5. Divide by 3, we get x equals 5/3. Over here, if we add 1 to both sides, we get -3. When you divide that by 3, you get x equals -1. That's the two solutions. Now, absolute value equations will usually have two solutions. Usually. They can have one. If the absolute value is equal to 0, then there's no 0 and -0, so it would just be one solution. And there's also this case where we could end up with something like this. 9 times the absolute value of x minus 4 equals -36. Can I split this into two separate equations now? No, because the absolute value part is not by itself, right? How do I get the absolute value part by itself? I have to divide everything by 9 or multiply by 1/9, but when I divide by 9 on both sides, on the left, the 9's cancel, and on the right, I get what? That's right. Now can I split it into two equations? I can, but if I do, I'm going to get two incorrect answers. Why are the answers going to be incorrect? Because we're saying here that absolute value is equal to a -4. Is it possible for the absolute value to equal to a negative number? It is not possible. This has no solutions. Okay. That's right. So you got to be careful. Absolute values, you have to keep that in the forefront of your mind. Absolute value of a quantity must be positive. Okay? All right. That's it for today.